So good news today, we are not starting anything new. Well, I hope that's good news. Maybe if you really didn't like yesterday, it's bad news, but we're gonna continue with graphing quadratics today, and we're still gonna be graphing them in standard form. Okay, so we're looking at that same concept. And I wouldn't even say that we're necessarily doing anything that's more difficult today. It's the exact same concept. It's just that now we're gonna have new A values, which means our quadratic's gonna sort of look fatter or skinnier based on what A is. But the exact same ideas of what opens up or down and making a table with 5 points and all of that good stuff. So let's say that we want to graph y equals 2x squared plus 12x plus 10. So first thing we'll notice, right, is now we have an A value that is not 1 or -1 today. And this is the good news about standard form. When we are in the form ax squared plus bx plus c, right, that's not as dependent because we are just plugging in values and A can be whatever it wants to be. So we are still going to be making a table, and we want, let's see, 1, 2, 3, 4, 5 places to input values. Just like we said yesterday, the middle of our table needs to be the negative b over 2a. Okay, so if we look up here at this quadratic, what does a equal? A is 2. What does b equal? 12. What does c equal? 10. So if we are going to do negative b over 2a, we are going to do negative 12 over 2 times a, which is 2. So now we have negative 12, I'm thinking ahead myself, over 4. And negative 12 divided by 4 gives us a negative 3. So over here in the middle of our table, we are putting in negative 3, right? And then just like before, we're going to count up and we are going to count down. So nothing different there. So negative 4, negative 5, negative 2, and negative 1. Now, if you accidentally made your table go the other way, that's not important. It doesn't matter as long as you have those values. And so now we're just going to start plugging each of these in. So in our calculator, the only thing we put in parentheses is the actual number we see in the table. So 2 parentheses, negative 5 close parenthesis squared. Plus 12 parentheses negative 5, right? We're putting that negative 5 in for anywhere we see x, and there's 2 of them. Plus 10, and we get out 0. Okay, so now we're going to plug in negative 4. So I just prefer to move my cursor up and over. Again, you could do this all by hand, but if you have a calculator, why would you? Okay, so we have negative 6. Then we're going to switch and do negative 3. That gives us out a negative 8. Now, from our rules yesterday, we know we should see symmetric values down here. So it's going to be really important that we have some matching output values here. So let's put in negative 2. Perfect. Negative 6, which is exactly what we should get. So we better get out of 0 here. So let's check it and see. Excellent. We get out 0, so we have that nice, neat, symmetric look. And then just like we did yesterday, we're going to plot these on the coordinate plane. Now we're going to notice today when we plot them, our shape looks a little bit different. So if I have 0, negative 5, which I guess, let me ask you this. If a is 2, should we be graphing a parabola that opens up or one that opens down? Yeah, they should definitely open up because a is positive. So while it might be a little bit fatter or skinnier, right, it should still open the right direction. So negative, oops, I plotted this wrong. I wasn't thinking. Negative 5, 0. Negative 4, negative 6. Apparently talking and graphing is difficult. Negative 3, negative 8. Negative 2, negative 6. And negative 1, 0. And here's our parabola, right? Now notice, right, this looks skinnier than the parabolas that we have seen in the past. And that's because the larger the A value is, the skinnier our quadratic is going to get. Okay, but using that same method we saw yesterday, we're still going to be able to get a nice, neat graph, regardless of how fat or skinny that quadratic actually is. Okay, so let's look at another one. let's say we have y equals negative 4x squared plus 16x minus 11. Start out the same way, make a table. 1, 2, 3, 4, 5. Okay, we want negative b over 2a. So in this particular case, our a value is negative 4. B is 16. And c is negative 11. What value are we going to start with in the middle of this table? So we should be calculating negative b over 2a, right? So in this case, negative b, so a negative 16 over 2 times a, which is negative 4. So negative 16 over negative 8 gives us a positive 2. So we're going to count up and down. And we're going to start plugging in values. Again, the only thing that should be going in parentheses is the actual number. So the negative 4 is outside, 0 squared plus 16. I mean, this should be a pretty straightforward answer of one that you can do without a calculator, but okay, so we get negative 11. So I want you to tell me when we plug in 1, what do we get out? And we should say 1. When we plug in 2, what do we get out? We should say 5. So what value when we plug in 3 is going to be really important that we get? 1, right? So let's double check and make sure when we plug in 3, we get out 1. And so what value do we need to get out for 4? We need to get out negative 11. So let's just double check ourselves. It's always important. It will help us know if we made a mistake. And then again, we can just go over here and graph this. So according to our information that we have here, is this parabola going to open up or down? Right, this should open down because our a value is negative. Now, mine's going to be a little bit off the graph because I'm using this 10 by 10 grid, but I don't have much of a choice here because with quadratics, those are just the points next to it. So I'm going to have to go off a little bit. So 0, negative 11, 1, comma 1, 2, comma 5, 3, comma 1, and 4, comma negative 11. Okay, and so you'll notice as that a value got bigger, I mean, it's negative, but 4 is bigger than 2, so it's flipped upside down for the negative, but it's even skinnier because of the a value being larger than 2. Okay, we are going to look at one more today, and there's sort of one more odd piece. I've been making everything work out pretty nice and neat in terms of finding those values. But that doesn't have to happen all the time with quadratics. So let's say we're given y equals negative 2x squared minus 10x minus 14. Okay, so we're making our table. Anytime we're asked to graph a quadratic and it's given to us in standard form, we should start by making a table. So we're going to find our a, b, and c. So a equals negative 2. B is negative 10. C equals negative 14. So which is going to be correct for when we say negative b over 2a? Right? The negative of negative 10 is positive 10 over 2 times negative 2. Right? So our 10 should be positive. We have this negative 2 down here. So that's going to give us 10 over negative 4. And now we run into this dilemma of we don't get something that divides nice and even. Yes, you can use a fraction, and I'm the one who usually says fractions, fractions, fractions. But I think for the majority of you, you are going to prefer to turn this into a decimal. At least turn it into a mixed number. Okay, and I'll show you why here, because when we put this negative 2.5 in the middle of our table, absolutely you could start counting up and down by 1. But if we do that, we're going to be following a decimal all the way through. And that starts to get to be a big pain in the butt. Okay, following all those decimals can be really difficult. And so if we think about a number line, okay, so we have 0, negative 1, negative 2, Negative 3, I didn't number this well, negative 4. Okay, and we have negative 2.5 here. Okay, it's going to be much wiser for us to find values that then take us to a whole number, an integer value, I should say, okay, where there's no decimals involved. There isn't a correct answer of what you go to. You can pick anything. The key, though, for it to be symmetric is that however much you jump to the right is the same amount you have to jump to the left. Now, my personal preference, okay, is I sort of just go 1.5 out because I don't like points to be so close together. Though the majority of my students, that's not their preference. The majority of my students like to just go 1/2 each direction because they know the number directly above and below. And that's totally fine. Okay, so if you just want to go to negative 3 and negative 2, that's fine. And then again, once you're here, you don't have to jump 1/2 amount again, as long as whatever amount you jump here is the same amount that you jump here. So if I'm going to the right one, I need to go to the left one. So that would give me a negative 4 and a negative 1. So the key is, right here I'm subtracting 0.5 and here I'm adding 0.5. Here I'm adding 1, here I'm subtracting 1. So whatever value it is that you sort of add has to be the same value that you subtract. And my suggestion is that you get away from that decimal as fast as you can. Okay, and then everything else ends up being the same. So now we're going to plug in the same. So negative 2 parenthesis, negative 2.5 closed parenthesis squared, minus 10 times negative 2.5. Okay, and you're going to see, right, this gives me out a decimal. So I have negative 1.5. I can't avoid that. It is the vertex. The vertex is a decimal. We've tried to avoid them in the past because we could pick other points, but there just simply isn't a different vertex. Okay, then I'm going to go up here and replace this maybe with negative 3. And over here, I'm going to replace this with negative 3. There's a delete button up here that I'm using to sort of get that out. Okay, and that gives me a negative 2. Okay, so same thing. What do you get when you plug in negative 4? We get out negative 6, which means when we plug in negative 2, what value do we need to get out? Right, we need to get out negative 2, so let's check our work, make sure we didn't make a mistake. If you don't get negative 2 here, that's a good sign that you either messed up on your vertex or you didn't count evenly. So you should go back and check your work. So same thing, when we plug in this negative 1, what do we need to get out? It better be negative 6, and it is, so we know we have good values that are nice, neat, and symmetric. Okay, so we can now plot these on a coordinate plane, and again, it's not my favorite, but it's just what we're gonna have to do. We're gonna have to approximate that vertex. Okay, is this parabola gonna open up or down? It will be down because our A value is negative. So I'm gonna plot negative 4, negative 6. Negative 3, negative 2. Okay, so negative 2.5, negative 1.5. And this is why I tend to avoid just going by 1/2, because those points end up so close to each other that I tend to sort of do 1.5 and then 1. But that's just my personal preference. Okay, so negative 2, negative 2, negative 1, negative 6. And there is our parabola.